Hello everyone, good evening. Welcome to this Fall 2020 University of Dallas Practicum presentation event. First, I would like to introduce myself. My name is Sami Abid. I am the MS Business Analytics final semester student. At this special moment, I would like to thanks to my family, especially my parents, my mom, my dad, and my wife for their all over support through my educational journey. And I would like to thank to Professor Shafkat, Professor Ramades, Professor Beltona, and Professor John Coleus for their all over help, support, and knowledge throughout this wonderful educational journey at the University of Dallas. My today's presentation is about forecasting average price household in the United States. Basically, it is a time series study which will focus on 1 year forecasting the price household in the United States. Contents, background, objectives, methodology, data sources, data processing, exploring data, forecasting method, result, and conclusion. As we all know, housing is one of the largest industries that helped and led the US economy out of the many uncertain periods, created jobs, and boosted the manufacturing during the critical times. As a result, there has always been a significant impact of the housing sector on the real sector of economy. As the main objective of this analysis to forecast the national average price household for 1 year from now, that it encompasses the ongoing down or up price trend in the housing market. So now the main questions are: till what extent the downward or possible upward price trend further go? Does this mean that it will take the housing market more than a year to recover from the current blow? So these are the two questions that I tried to answer them in the next slides. Objectives. For me and also other US residents, the housing price change has been an important aspect. And it is very, very important to understand the aspect so that we can be better prepared by utilizing historical trends to predict future outcomes. The analysis focused on exploring average sales house price sold time series data and comparing methods for predictive analysis. Basically, the primary analytic goal of this analysis is to determine a best fit model so that we can use it to provide a 12-month forecast of future average house price sold from now in the United States. Methodology. So the data set is obtained from Federal Reserve Economic Data, Fred. Basically, as we all know, Fred is a very well-known website with having more than 765,000 economic time series data from 96 different sources. So as far as this analysis, relatively many analyses and studies have been conducted on house price forecasting using time series data with applying different modeling approaches. So this analysis would focus on exploratory time series analysis and forecasting. The expected outcomes and deliverable from this analysis is to build a forecasting model with more than 95% accuracy to forecast a 12-month average house price sold in the United States. Data sources. As I already said, the data sets are obtained from Fred, and it is the time series data from 1980 to 2020 with 162 quarterly observations and 4 variables. The primary variable is the average sales price of houses sold for the United States, and predictive variables are gross domestic product, unemployment rate, use recession probabilities. As an important part of this analysis, the data processing or feature engineering is done in 4 different phases. Phase 1, exploration. I uploaded the time series data into R. Check the data trend, seasonality, and correlation between the predictor and non-predictor variables. Split the data into training and test data. Second phase, forecasting method, where I check the white noise on the time series data. And I applied 3 different models. The first model is simple time series regression with considering the trend and seasonality. The second model is the same kind of model, but without considering the trend and seasonality. And the last model is the ARAMA model. And then the final model application and checking the model accuracy and performance on the new data. The third phase is the forecasting result, where I'm interpreting the forecast outcome for the 12 months average house price for in the United States. And the last phase is conclusion. As part of the exploring data, first we were checking the correlation between the predictor and non-predictor variables. As we can see the figures, so there is a strong correlation between the average house price sold in the United States and the gross domestic product. And there is low negative correlation between the average house price sold and unemployment rate variables. As part of the data exploration phase, secondly, I conducted the box L Jong test. Based on that test, the figure shows the p-value is less than 0.5%, which clearly indicates that it is a non-stationary data set. So in non-stationary data sets, the trend or seasonality may be valuable within the predictive model. So the average household price index, we would not remove the seasonality and trend from the model. So as a result, I didn't conduct additional data transformation from this point. As part of the data exploration phase, finally I divided the data into 75% train set and 25% test set. So the frequency for both is quarterly, and the train subset is from 1980 to 2020, and the test subset is from 2012 to 2020. Forecasting method. In this phase of the analysis, I applied 3 different models on the data. The first model is the simple time series regression model without considering the seasonal and trend. So basically this model utilized the optimal combination of variables to obtain the highest performing time series. As we can see the results for the residuals, the data is almost normally distributed around the 0. But there are some slight dips that align with the visible data trend. And as we can see the lag ACF plot, it shows that more than 0.5% of the data spikes are outside of the blue line, which clearly indicates that the data is not a white noise data. As we can see the coefficient, the p-value is less than 0.5% with adjusted R-square 0.95%. And as far as the accuracy test, the ACF, RSME, and MU shows different figures. The second model that I applied on my time series data is time series linear regression model. Basically, it is the same model, but this time I'm considering the seasonality and trend. As we can see the result, the residual shows that the data is normally distributed around 0, with some slight dips that align with the visible data trends. And as we can see the lag ACF, we can say more than 0.5% of the the dips are outside of the blue line, which clearly indicates it is not a white noise data. And as we can see, the coefficient and accuracy, it is also improved compared to the first model. Finally, the third model that I applied on my dataset is the auto-ARIMA model. An auto-ARIMA model is a non-seasonal model. And as we can see the result, the residual shows normal distribution around 0. And as we can see the lag of ACF, the spikes are inside the blue lines, which clearly indicates that it is a white noise data. And as we can see the coefficient, it is improved compared to the first and second model. And as far as the accuracy test, as we can see here, the ME dropped compared to the first and second model. So we can say that a ARIMA model is the best fit model for our 12-month average house price sold index forecast. Since the auto ARIMA model is the best fit model for our forecast, so to further validate the model, I applied the model on my trained data. And as we can see the result, the forecast displays a close visual resemblance to the original data. In addition, if you see the quarter 1 of 2012 to quarter 4, the high 80% and the high 95% confidence level indicates increased forecast index. Forecast results. After the validation, I applied the auto-ARIMA model on my data. And as per the result, we can see from the third quarter of 2020 to the fourth quarter of 2021, we are high 95% and low 80% confident that the average house price sold in the United States will further increase. So auto-ARIMA model is a model which is frequently used because it has a strong influence on the historical data. It is very important to consider the limitation of this model because the auto-ARIMA model do not consider the external factors. In some cases, the historical data may not be enough to provide accurate future forecast. Conclusion. As we can see the results using the auto-ARIMA model, the average house price sold forecast for over 12 months has upward trend, and the 95th percentile of the forecast indicates a possibility that the index will increase rather than decline. So as we can see, the current upward price trend would further go, which means that it will take the housing market more than 1 year to recover from the current market blow. These are the references that I used in my analysis. Thank you so much for being with me till the end. If you have any question, suggestion, please leave it in below comment section. Have a good evening.